Okay, in this video, we're going to be talking about the Calc BC series FRQ, and I'm going to beg you to never skip this question. I think there's a lot of points that a lot of people can get on this, and it's really worth studying and getting as many points as you can. So let's take a look at what I mean by this. So there are certain things that you'll be given. So you might be given the first few terms of the series, and here are some examples of what that looks like. So you can see in 2015, they basically just gave you some terms and the nth term. In 2018, they gave you terms and an nth term. They just kind of ask you about it. What's kind of interesting about 2018, I think, is that it's virtually identical to another problem, at least the series that you end up with. So then in 2022, more of them. They're just giving you the terms. So be familiar with what you're going to be given because you're going to have to work with it. So you also might have some terms and then how to find the values of the derivative, because we're going to know how to work from that to our series. So for example, 2016, you were told f of 1, f prime of 1, and then how to generate more values of the derivative at 1, and we're just going to make a table of values and work with that. Same sort of thing in 2017, give you f of 0, f prime of 0, and then how you generate more values of the derivative. So they're a little recursive. You just kind of have to think about them a little more. 2023, same deal, f of 0, f prime of 0, and then kind of this complicated description of how to find f double prime, f triple prime, which is literally just find the derivative of f double prime. So I don't know exactly why they gave that to you, except the question you'll see later asks you to find the fourth derivative in as a function of x. So we'll be doing that. And then additionally, this one's the biggest one, like just in terms of the size of the given information. They gave you a graph of a function with its tangent line and then a table of values, and they ask you to do some stuff. So this is what the problem givens will look like essentially. And if you know what to do with that, you can almost always get a whole bunch of points. So here's primarily what you'll do. You're going to have to find the first few non-zero terms and the nth term of the series for the function, or some other series very much related to the function. So if we know Taylor's formula, which is basically it's the nth derivative evaluated at a, the center, over n factorial. So nth derivative over n factorial, x minus a to the n. That's what we're doing. So you can see it's the value of the function. And then the first derivative, 1 factorial to the first. Second derivative, 2 factorial to the second. Then it'll be third derivative, 3 factorial to the third, and so on. So once we have those values of the derivative, we're just going to slot them in here, and we're going to just make our series. So anybody can do this. You should not be skipping this problem. You shouldn't go into the exam thinking, I'm just not going to do the series question. Now what I want to do is take a look at some problems that basically use this concept, right? So here we have 2016, right? We're given f of 1, f prime of 1, and then how to find more values of the derivative. Part A said write the first 4 non-zero terms and the general term of the series for f about x equals 1. So first thing that I would do is I would set up a table with columns n and fn of 1, the nth derivative at 1, and I would start filling it in, right? So we were given the 0th derivative, which is the value of the function, which is 1. We were given the first derivative, which was negative 1/2. Usually there's a point associated with just using those. And then we have to generate additional terms on our own. So I just subbed in the value of n into that formula, and it gave me the second derivative is 1 over 2 squared, and then the third derivative is negative 2 factorial over 2 cubed, which maybe you would simplify, maybe you wouldn't. You don't really have to simplify it unless it turns out you need to. So from there, what we would do, take those values and plug them into that formula that we had, right? Which is going to just look like this, right? The value of the function. First derivative, 1 factorial, x minus 1 to the first. Second derivative, 2 factorial, x minus 1 to the second. Once you know what you're doing, the thing that you will screw up most often is forgetting the center, that quantity x minus 1. Don't forget it. And then we just keep going. We get the third derivative over 3 factorial, and then x minus 1 to the third. So we've written the first 4 non-zero terms. The nth term, you just take that formula for the nth derivative, put it over n factorial, x minus 1 to the n. Like, it's very straightforward substitution. What I did was I then simplified this a little bit, and I ended up with this. So it's 1 minus 1/2 quantity x minus 1 plus quantity x minus 1 squared over 2 squared times 2 minus x minus 1 cubed over 2 squared times 3 factorial, and you just kind of go from there. Actually, I think that that's probably 2 to the third. It looks like I wrote it wrong, or maybe it's just like hard to see. You should make it so that you can actually see what people are doing, or what you're doing rather when you're working on these. And then it looks like when we simplify that nth term, n minus 1 factorial over n factorial is just 1 over n, so that's simplified. We have negative 1 to the n, 2 to the n, x minus 1 to the n. So that is definitely, in that fourth non-zero term, it is definitely cubed over... I'm not really sure why it's that, though. Oh, I do know. So the reason that it works out to 2 to the n times n is that you have like 2 squared times 3 times 2 times 1. So that's 2 squared times 2 is 2 cubed, and then times 3. So the nth term does work out for that. That's my bad. Probably going to edit a lot of that out. Okay, let's take a look at another one. So we have this, right? You're given enough information. This one's kind of a weird question, actually, because it doesn't say, like, just find the first 4 non-zero terms and the general term. It's like, these are them. And usually they do that because you're just going to need it in another part, and they don't want to risk you getting that wrong and then getting everything wrong. So I'm going to do this the same way. I'm going to make a table. So here's my table of values. I use the given value of f of 0 is the 0th derivative. The first derivative is given as 1, and then I follow the formula. And you can see I'm like showing my work there, right? It's negative n times the nth derivative at 0, right? And so that's the formula, though, keep in mind, for the n plus first derivative, right? So the n plus first, when you're at 2, that's really 1 plus 1. So you're looking at the first derivative. When you're at 3, that's really 2 plus 1. So you're looking at the second derivative to pull off your values. I tried to show that in the table. When we get those values, you might recognize them as factorials. If not, you're probably okay anyway, because what we're going to do is just use that formula that we memorized and sub right in, right? So we have the value of the function, first derivative, 1 factorial to the first, second derivative, 2 factorial to the second, third derivative, 3 factorial to the third, fourth derivative, 4 factorial to the fourth. Say it with me, and you kind of can't screw that up. We do need to find the nth term of this series, or the general term of the series. So I'm going to just simplify this right away. I kind of got lost while I was doing it and forgot that they had like given us the original. You can, from the original, just guess what the nth term is. And so like you should do that even if you can't work out anything else. Like work out that nth term, right? So I would say that the nth term looks to me like it's definitely x to the n over n. And then you just have to work out what's going to make it be positive when n is 1, negative when n is 2. So it's like you need a positive when you have an odd number, which means just negative 1 to the n plus 1. Because if you add 1 to an odd number, you get an even, and negative 1 to an even number is positive 1. So that's how I'm working that out. You could work that out without doing the rest of the problem, and you should, because I bet there was points associated with that. We're going to look at another one. We're basically just going to plow through as many of these as we can. I'm trying to show you how to do them, but also just say don't skip this problem. There's a lot of gettable points. All right, this is 2018. So you're given the series for the natural log of 1 plus x. In part A, you were asked, write the first 4 non-zero terms and the general term of the Maclaurin series for f. F is x times the natural log of 1 plus x over 3. All right, here is a thing that you can do. You can just do a substitution, right? So the question is, what are you plugging into the natural log of 1 plus x to get the natural log of 1 plus x over 3? You're plugging in x over 3. Everywhere you see an x in the given series, replace it with x over 3. That's going to look like this. And that's like a good start. You could almost stop there. That's not the series for f, but it is the series for natural log of 1 plus x over 3. We don't need to simplify this, but I'm going to. Generally speaking, you don't want to like expand factorials. You also don't want to like actually, raise things to power. So I'm going to rewrite this as just x over 3, and you can see the x over 3 squared, I made x squared over 3 squared. The x over 3 cubed, I made x cubed over 3 cubed. So I'm not trying to like find 3 cubed, 3 to the 4th, etc. Then that nth term, negative 1 to the n plus 1, x to the n over 3 to the n times n. And that's natural log of 1 plus x over 3. We needed x times that. So I'm just going to multiply both sides of this by x, which means on the left-hand side, you just get x natural log of 1 plus x over 3. On the right-hand side, just increment each of the exponents for x by 1. So our x becomes x squared becomes cubed, etc. In our last term, the x to the n just becomes x to the n plus 1. And that's it. You're getting a lot of points by doing this. Don't skip this question. I'm begging you, do not skip the series question. Let's look at another one. Basically the same thing. And also you can tell the 6th question is pretty much always going to be the series question. Pretty much always looks very similar to these. Obviously, we're going through all of them. This is 2019. You were given the graph. You were given a table, right? The third degree Taylor polynomial. Now notice they've given you the second derivative and third derivative and fourth derivative. They didn't expressly give you the value of the function or the value of the first derivative. So the information has to be here somewhere. My advice to you would be to definitely remember this. And this is a little known, I don't know, it's not little known, but it's lesser known than it should be. Tangent lines are the first degree Taylor polynomial. If you can write a tangent line, you can write a first degree Taylor polynomial like immediately, right? So because of that, we can just look at the graph with its tangent line. The tangent line has a y-intercept of 3 and a slope of -2. That is 3 minus 2x. So that's what we'll start with. Then from there, we will just use our formula, right? So here's what that looks like. So it's 3 minus 2x, the tangent line, and then it's going to be second derivative 2 factorial to the second, third derivative 3 factorial to the third. I simplified it because I'm trying to match the scoring guides, but you can actually leave that. It'll be harder to work with, but it's fine. Simplifies down to this. All right, I think I got one more that looks like this, and then we'll move on to the next kind of topic that I'm saying you should never skip the series problem because you can do it. Let's look at it. So this is 2023. We are given f of 0, f prime of 0, and then the second derivative, the third derivative. The first part says find the fourth derivative. So starting with the third derivative, just use the product rule. First derivative of the second, don't forget the chain rule, plus second derivative of the first. We just get that. Pretty sure that's a point. So like, why would you have not done that, right? Write the fourth degree Taylor polynomial. At this point, I'm thinking I'm going to need to make a table of values. So here's my table. It's n and then the nth derivative at 0. So the value of the function was 2. That's the 0th derivative. First derivative is 3. Second derivative, we start employing these formulas that they gave us, right? So it's the negative of f of x squared. So the negative of f of 0, which is -2. And then the third derivative is -2x, but x is 0. So -2 times 0, f prime of 0 is obviously 0. The fourth derivative kind of looks like it's going to be all zeroed out, but it's not, right? Because you have that -2 times 0, f double prime of 0 times 2 times 0. That's obviously 0. But then that last part from the product rule, you get -2 times f prime of 0, -2 times 3 is -6. Then we just use our formula. So this looks like a hard problem. It's actually not a hard problem, right? We're going to get all these points. Plug it in, it's the value of the function, and then the first derivative, 1 factorial to the first, the second derivative over 2 factorial to the second, the third derivative, 3 factorial to the third, fourth derivative over 4 factorial to the fourth. One thing you might notice, if a coefficient is 0, I still put it in there because I don't want to screw up the pattern. And also you have like 15 minutes on average to work through these problems. In my experience, you don't really need 15 minutes. So I write it out, then I'll go back and simplify it. This kind of works its way down to this. So you are not going to skip the first part of the series problem because if you know Taylor's formula and you know how to work with these things, that's almost always enough. So that's the first part of it. The next thing that you're going to be asked to do is either integrate or differentiate a series, but honestly, they are called power series. You literally just use the power rule or reverse the power rule. So there's no reason to ever skip this. Also, when you're integrating, you're almost always, actually I think you are always, doing a definite integral. So there isn't even a plus c to solve for. So let's take a look at what this would look like. So here we go. We got 2015 part B said, write the first 4 non-zero terms of the Maclaurin series for f prime, the derivative of f, express f prime as a rational function. Don't worry about that part immediately, but let's just find f prime. So f of x, we're kind of like given, right? So we only need the first 4 non-zero terms. So I wrote out the first 4 non-zero terms of f, and we're looking for f prime. Literally take the derivative of this thing, right? This is power rule all the way through. So you just get 1 minus 3x plus 3 squared x squared minus 3 cubed x cubed. It's pretty easy to guess the nth term of this if you had to, but you're not asked to. So then the next part you do need to know a little bit more. I recommend that you memorize e to the x, sine of x, cosine of x, and 1 over 1 minus x. In this case, 1 over 1 minus x is super useful because that is the sum of a geometric series, and this is geometric. So I would say that the common ratio is negative 3x divided by 1, negative 3x, or 3 squared x squared divided by negative 3x, which is negative 3x, or negative 3 cubed x cubed divided by 3 squared x squared, which is negative 3x. R is definitely negative 3x. And then we just sub it straight into the sum of a geometric. It's the first term over 1 minus the ratio. So 1 is the first term of the series for f prime. Over 1 minus the ratio is negative 3x. We get 1 over 1 plus 3x. So again, you're getting a lot of points if you're not skipping these things. So do not skip them. Just dive right in. Let's look at the next one. 2017. So we already did part A for this. It was like find the whatever it was, find the Maclaurin series for f and write the general term. So they gave us the Maclaurin series because of part C. If they hadn't given it to us, they would have to like look at everybody's wrong answer to part A and then use it for part C. They gave it to us. We're trying to find in part C the first 4 non-zero terms and the general term for the integral from 0 to x of f of t dt. Write that down, right? So g of x is the integral from 0 to x of f of t. So I'm changing my f, and every x becomes a t. So I have t minus t squared over 2 plus t cubed over 3 minus t to the fourth over 4 dt. Integrate this thing, right? The integral of t is 1/2 t squared, and then you get minus t cubed over 3 times 2 plus t to the fourth over 4 times 3 minus t to the fifth over 5 times 4. You're going to plug in x. All the t's just change into x's. Then when you plug in 0, since everything still has a t, everything disappears. So we just get this. We're supposed to find the nth term. What I did was I just looked at each term and kind of worked out what I thought was happening, right? So when I'm at like 5, for example, when I have x to the fifth, I see a 5 and a 4. So I'm thinking it's x to the n, and then n minus 1. Now I need to make sure that it alternates the correct way. When n is odd, I need negatives. When n is even, I need positives. I forgot the word for the opposite of negative. I need positives. So I can just say it's negative 1 to the n and it'll match up. And just go back and check. When you look at the answer key, you'll see the answer key has a slightly different thing, I think. I think that they have like x to the n plus 1, and then an n plus 1 and an n, and then you probably need to change the negative 1. Any valid nth term is going to get you the points. You don't need to match exactly what they have, because how do you know what's in their head when they're making it? Let's take a look at another one. So write the third degree for whatever. We probably did this one already, so I'm just going to import that answer. And then let h be the function defined by h of x equals the integral from 0 to x, f of t dt. Use the Taylor polynomial from A to find an approximation for h of 1. So h of 1 is the integral from 0 to 1 of f of t dt. So I'm just going to write that down. H of 1 is approximately, because we don't have an infinite series, we just have a truncated series, so we're not getting the exact value, we're just approximating. 0 to 1, change all the x's into t's. And now just integrate and do it, right? This is now just a pretty simple reverse the power rule problem. So h of 1 is approximately, you get 3t minus t squared plus t cubed. I don't need to read the whole thing. From 0 to 1, when you plug in 0, everything is gone. So all you really need is when you plug in 1. Now, what I'm going to do is simplify this, but I shouldn't. I should leave it the way that it is. Simplification, not required. Get it to something that you can do on a scientific calculator and just like move on with life. But again, do not skip these. Let's look at one more that is of this sort of variety. So we have this series that we're given. This is 2022. Write the first 4 non-zero terms and the general term for an infinite series that represents f prime. Just do it. Just start taking the derivative. Like, I think people are too intimidated by the series questions, right? Power series, use the power rule. Here we go. I just use the power rule all the way through, right? And you just get this. And it's nice and clean. This is literally just using the power rule. That is all there was to that type of question. Okay, so let's move on to the next thing that you might be asked to do. Okay, multiplying two series together. This is another thing that they ask you to do occasionally. It's not all the time, but in recent years, it seems a little more common. So what you want to do when you're multiplying two series together is literally just write out each series to the desired degree. and then multiply them like they're just polynomials, like you're in algebra 1 or algebra 2, and like kind of collect like terms. That's literally what we're going to do. You should memorize e to the x, sine of x, cosine of x, 1 over 1 minus x. You got to walk in knowing those. I have another video where I go over those. If you want to look for it, have at it. Let's take a look at these problems. So 2015, we are given this series, and then part C said, write the first 4 non-zero terms of the Maclaurin series for e to the x. So since you have that memorized, that's easy to do, right? It's just like all the powers, all the factorials, and you're adding them up. So it's 1 plus x squared over 2 factorial plus x cubed over 3 factorial. You could go on literally forever, but we only need the first 4 non-zero terms. Use the Maclaurin series for e to the x to write the third degree Taylor polynomial for g of x, which is e to the x times f of x. Okay, so f of x is the thing that they gave us. We need to get up to the third degree. So the safest thing to do is to write both e to the x and f of x out to their third degree, and then we'll just start multiplying. So let's see what that looks like. So this is e to the x times f of x, both written out to their third degree. Conveniently, on the they actually just gave us up to the third degree for f of x because they want you to get this right. So what I'm going to do is like old school algebra 1 or algebra 2 style, just like show some arrows, right? So like you have to take 1 and multiply it by everything on the right. So I showed some arrows there. That gets you up to x cubed, right? So you get all the way up to 3x cubed. Now you're going to take x and multiply by everything on the right, except you stop when you get to x cubed. So x times x is x squared. X times negative 3 halves x squared is negative 3 halves x cubed. We don't want to do the next term because that would be fourth degree and we just don't need it. So we stop there. Then we go to x squared over 2 factorial, multiply it by everything on the right, but we stop when we get to x cubed as our power. So x squared over 2 factorial times x is already x cubed over 2 factorial. If we try to go further, we'll be at x to the fourth. We don't want that. Then we look at x cubed over 3 factorial, and we try to multiply it by anything on the right. But if we do, we're already higher than x cubed, so you don't contribute any terms there. So this is what we get. Now, on these types of problems, there is no way to know this. They don't really say this anywhere, but I think that to get full credit for this, you do need to kind of like factor by grouping. So you need to have like an x with a coefficient, an x squared with a coefficient, an x cubed with a coefficient. They don't want you to just like leave the mess that I currently have there. So what I did was I just kind of factored by grouping. The x is by itself, and then for x squared, there are coefficients of positive 1 and negative 3 halves. For x cubed, there are coefficients of 3, negative 3 halves, and 1 half. You can simplify it down to, you could leave it there in that like unsimplified form that I have, or you could simplify it down. I think it's a little cleaner and it's not really hard, but also if you do it incorrectly, you lose points, so it's probably not worth it. Let's look at the next one that is of this variety. It's almost identical actually. Write the third degree for f. That was part A, we already did that. That's this. Write the first 3 non-zero terms for e to the x again. So make sure you know e to the x, right? So the first 3 non-zero terms for e to the x are going to be, I actually didn't write that out explicitly. I think I would get credit anyway because clearly I've done it, but I should have written 1 plus x squared over 2 factorial. Kind of jumped the gun on that. So I wrote that down, and then I wrote, I only need to go up to the second degree of f because the third degree is already too high, and we only want the second degree polynomial for e to the x times f of x. So I went with this. I did my arrow things again. I distributed again, and I stopped when I got to x squared this time. Then we use the super secret rule that you need to like collect like terms. So we end up with basically this. We have 3. The coefficients of x are 3 and negative 2, so I didn't bother to write that. You just get plus x. The coefficients of x squared are 3 halves, negative 2, and positive 3 halves again. So that's 3 minus 2, which is just 1. So we get 3 plus x squared. So all pretty similar. Let's look at one more that, to be honest with you, isn't really the same, but definitely sort of feels the same. When I looked at it, I was like, oh, it's this type of problem. It's really not. So let g be a function. Well, in part A, we had already figured out this, right? By using that formula that we memorized and we're not afraid to use. So we had already found this in part A. This is 2023. This is when I'm making the video, just last year. So g is going to be the function such that g of 0 is 4, g prime is e to the x f of x, and we want to write the second degree Taylor polynomial. In my mind, this is like, I got to make a table, but it's more complicated, well, a little more complicated than that. So here's what I did. G of 0 is 4. G prime is given as e to the x f of x, so then g prime of 0 is e to the 0 times f of 0. F of 0, we know from our Taylor polynomial, just plug 0 in and you get 2. So f of 0 is 2. Also, probably in the given information, they gave us that, but g prime is 2. G double prime, we have to use the product rule. It's first derivative of the second, second derivative of the first, plug in 0. E to the 0 is 1, so really we have f prime of 0 plus f of 0. F prime of 0 is the coefficient of x in that Taylor polynomial is 3, but also I think it was just given. So we have e to the 0 is 1 times 3 plus f of 0 is 2 times e to the 0 is 1. So we have 3 plus 2 is 5. So once we have that, it's just like write the polynomial using our formula that we're not afraid to use, and we get this. So full disclosure, this isn't really the same thing. I just kind of like feel like it's the same thing. It certainly looks like the same thing. So those were the best examples I had of this idea. Don't be afraid to multiply series. Don't be afraid of the series problem at all. If you know a couple of simple things, you're going to get a lot of points. All right, let's move on to the next topic. All right, I'm kind of oversimplifying here, but you are basically going to have to use the ratio test quite a bit, specifically to find radius and interval of convergence. Ratio test is like pretty much my favorite thing to do in Calc 2. You're going to need to potentially use alternating series test, geometric series, p-series, harmonic series, alternating harmonic series as justifications for endpoints of an interval of convergence. But again, if you can do the ratio test, you can get a bunch of points on the series question. So let's take a look at some of these. So first up, we have this one from 2015. We're just told use the ratio test to find r. So if we're just using the ratio test, we're going to set it up. So it's a sub n plus 1. So it's the n plus first term times the reciprocal of the nth term. So I take n plus 1 and I plug it in everywhere in that nth term. So negative 3 to the n plus 1 minus 1 is negative 3 to the n. And I always break that down to negative 1 to the n and 3 to the n. I don't like to have a product to a power when I'm doing the ratio test. Personal choice. I mean, it's up to you. Then we end up with x to the n plus 1 over n plus 1. Then we just take the reciprocal of the nth term. But again, I broke that negative 3 to the n minus 1 into negative 1 to the n minus 1 and 3 to the n minus 1. We have to take the limit, so you got to be kind of good at taking limits to infinity. I usually write it like this. The only thing that has to stay in the absolute value is x. N is going to infinity, so n is definitely positive, so we can just take it out. The negative 1 to the n, the negative 1 to the n minus 1, the absolute value is just going to get rid of those anyway. And then we have 3 to the n over 3 to the n minus 1, which I've chosen initially to just write as 1 over 3 to the negative first. Then I simplified this, so n over n plus 1 just is 1 as you go to infinity. So we end up with 3 times the absolute value of x. Now what you want to do from there is just say that your series is going to converge. It actually converges absolutely, but we don't need to talk about that here. Converges as long as 3 times the absolute value of x is less than 1, which means the absolute value of x is less than 1/3, which means that r, our radius, is 1/3. You actually have to do that last step where you say like the radius is 1/3. Otherwise, like, what have you really done, right? You haven't really conveyed what they asked you to find. So that's one example. Let's take a look at another one. So we're really focusing on the ratio test for these. Determine the radius of convergence for this Maclaurin series. This is 2021, is it? Yeah, 2021. So again, same thing, right? We do the n plus first term times the reciprocal of the nth term. So every n becomes an n plus 1. We're going limit absolute value as n approaches infinity. So negative 1 to the n plus 1, x to the n plus 1, 2e to the n plus 1 plus 3, and then times 2e to the n plus 3 over negative 1 to the n x to the n. That's just the reciprocal of the nth term. We take the limit, and it ends up looking like this. So we have 2e to the n. I rewrote 2e to the n plus 1 as 2e times e to the n to make it a little easier to see what's going on there. And then absolute value of x. When you go to infinity, you have basically the plus 3's don't matter, right? If you're going to infinity, they're so tiny. You have 2e to the n over 2e times e to the n. The e to the n's cancel. You have 2 over 2e. This is so hard to say for some reason. So you really just have 1 over e. 1 over e is that limit, and then the absolute value of x. Then we do the same thing again, right? So converges for this quantity less than 1, which means the absolute value of x is less than e. And again, you want to say the radius of convergence is, and then in this case, it was e. So you're going to get points if you do these things. So ratio test, spend a little time getting good at it. You'll be fine. 2016, really similar problem. So first 4 terms, in part A, we found this. And then what we're asked to do here is Taylor series for f about x equals 1 has a radius of convergence of 2, which means we got to work something out here, right? So this thing is going to converge absolutely. You start at 1 and you can go 2 in either direction. If you go 2 to the left of 1, you end up at -1. If you go 2 to the right, you end up at +3. So we know this thing converges absolutely between -1 and 3. The question is, what's happening at -1 and what's happening at 3? So if you just take -1 and you plug it in, you end up with something that looks like this. I'm just looking at the nth term, right? So it's -1 to the n, and then I'm plugging -1 in for x. So I get -1 to the n, and then I end up with -2 to the n, which I made -1 to the n times 2 to the n, and over 2 to the n times n. Cancel the 2 to the n's. -1 to the n times -1 to the n is actually just 1. It's always 1. So this is really 1 over n, which is clearly the harmonic series. So f of -1 is the harmonic series and will diverge because of that. Alternatively, you can like plug in some values and just see what you're getting. That's clearly, well, it's like 1 plus the harmonic series, but I would still say that diverges because it is the harmonic series. You're allowed to use harmonic as your justification. With f of 3, same deal. I just plugged into the general term. You get -1 to the n, 2 to the n over 2 to the n times n. The 2 to the n's cancel. This is the alternating harmonic. And again, if you just plug in, you get, you get this f of 3 is 1 minus 1/2 plus 1/3, 1 minus 1/4. This is going to converge to the alternating harmonic. So you don't need it converges because it's the alternating harmonic, I should say. You don't need the ratio test on this one because they literally gave you R, basically, the radius of convergence. So testing the endpoints, not as hard as people make it out to be. You just have to plug in for x, essentially, in the nth term, see what you get, right? And then use some of those things that you know. Let's take a look at the next one. So, the interval of convergence on this one was not including -1 and definitely including 3. So -1 is less than x is less than or equal to 3. Next up, 2018. So in 2018, determine the interval of convergence. We need this series that we got in part A, I think. Determine the interval of convergence. Ratio test again. So ratio test, anytime they ask for the interval of convergence, just think I need to use the ratio test, set it up, which for all I know is going to get you some points just by setting it up. So every n that you see becomes an n plus 1. You have the n plus first term times the reciprocal of the nth term. So -1 to the n plus 2, x to the n plus 2, 3 to the n plus 1, n plus 1, and then the reciprocal. When we simplify things, we end up, the only thing left is n over n plus 1. Remember, the -1 stuff is just gone because of the absolute value. Still need the absolute value of x. And then the 3 to the n over 3 to the n plus 1 just reduces down to 1/3. So we have this. The limit as you go to infinity is just 1, and then times the absolute value of x over 3. And then we do basically the same thing, but here we need interval. So we converge everywhere that quantity we just found is less than 1, which means the absolute value of x is less than 3, converges absolutely between -3 and 3. We need to test -3 and test 3. We're just going to plug them into the general term. So at -3, we plug in, we end up ultimately with 3 over n, which is just 3 times the harmonic series. That diverges. Then we plug in 3. We end up ultimately with -1 to the n plus 1 times 3 over n. That's 3 times the alternating harmonic. That converges. So again, harmonic and alternating harmonic keep showing up. It's good to know that the harmonic series diverges, the alternating harmonic series converges. Knowing that is useful. Our interval of convergence is -3, not include, -3 is less than x, less than or equal to 3. So ratio test can get you some free points. Harmonic, alternating harmonic can get you some points. Let's look at another example. So this is 2022. Use the ratio test, find the interval of convergence of the power series. So again, ratio test is being explicitly called out on this one. I don't know why they do that sometimes. They might just say find the interval, in which case in your head you would say ratio test, so whatever. Justify your answer. How are you going to do this without justifying your answer? But so we set it up, right? N plus first term. It's really the n plus first term divided by the nth term, but I think it's easier to think of it as n plus first term times the reciprocal of the nth term. We set up our limit. You end up with 2n plus 1 over 2n plus 3. That goes to 1. You have the absolute value of x squared, which means you need the absolute value of x squared less than 1. think of all the values. Sometimes I just graph x squared and I graph 1 and I look where it's below 1. You can see it's -1 to 1. We have to test our endpoints, but again, you plug in -1 to the nth term, you end up with -1 to the 3n plus 1 when you simplify that, but that still alternates positive, negative, so alternating, the terms decrease in magnitude to 0. This converges by the alternating series test. I also think it's okay to just write converges by alternating series test here. I think that is justifying your answer. I looked up the scoring guidelines, and I think that it confirmed that you were allowed to just say that. You didn't have to like run through everything. To be safe, and if you have time, you might want to run through all of the requirements, right? The terms alternate, they decrease in magnitude to 0, or they alternate, decrease in absolute value to 0. Those are like the two default ways of saying that. And then at x equals 1, we just get -1 to the n over blah, and that converges by alternating series test again. And so I think I forgot to write the actual interval. The actual interval in this case would be -1 less than or equal to x less than or equal to 1, right? Because we had convergence at both endpoints. So make sure you write that. I didn't, so I would be losing a point. You don't want to lose that point. So there's really only, I mean, I've really overgeneralized this. There are other things that they would sometimes ask, but I'm trying to convince you here to do the series problem. Do not skip it. I know a lot of people are just like throw their hands up when they see the series problem. No reason to do that. There's another big topic that might come up, and that would be error. You're almost certainly going to see error on this thing. I already made a huge detailed video about error, so I'm just actually going to link this thing below instead of going through it here. So find that, click the link, watch that video. You can get a lot of points on the series FRQ. Please give it a shot. Don't think that you can't do it. All right, I hope this was helpful, and good luck.